So we're starting to see AI move out of the data center. People talk about moving AI to the edge. The edge means different things to different people. In some cases, it means the edge of the network being sort of the base stations or the routers. And in other cases, people mean the actual client devices that are at the end of the connection, the smartphones or the IoT devices. So the reason, well, there's several reasons we see that are driving this trend. The data centers have created these really cool services to do voice recognition and language translation and photo processing. But now that they've become popular, these services are using more and more computers in the data center. And of course, the data centers have to pay for all of those. So it's actually, they're realizing it's cheaper to move some of this processing out onto the client. And that way, it reduces the load on their servers. That makes everything more scalable because as you add more users, they all have their own client device that can perform some of the AI service. So, but there's advantages to the user as well. If you're starting to use some of these voice services in your home, for example, and you want to turn the lights on, you want that to happen very quickly. So you don't really need the latency of going up to the cloud and back down again. Being able to do that processing directly on your phone, for example, would be a faster solution. And it would work even if, for some reason, your network connection is slow or not working. So it also improves privacy. You know, we've heard all the horror stories about Amazon Echo devices sending conversations up into the cloud. So if you do the voice processing locally, then you're exposing much less information to the cloud provider. So for all these reasons, we're seeing a trend toward moving AI into the client. The smartphones have kind of been leading this trend by adding AI engines into the smartphone processors. So, for example, the last two generations of Apple processors integrate what they call their neural engine. Samsung has a neural engine, Huawei, Qualcomm. So pretty much all of the leading edge phones today have some sort of hardware in the phone that accelerates these neural networks. One of the driving applications has been face recognition or 3D face recognition to be able to unlock the phone, and that requires more sophistication than some of the simpler, say, fingerprint recognition that has been done before. And so putting that AI engine into the processor allows the phone to do this 3D Face ID very quickly and not use a lot of power. But now that companies have introduced this technology into the high-end phones, we're starting to see it trickle down into lower-priced phones, mid-tier phones. Eventually, we expect to see it trickle down into lower-cost phones as well and become, you know, the bulk of smartphones will have this kind of technology. We're also seeing AI now move into the Internet of Things. You know, the voice assistants that I was talking about are becoming more popular in the home, and so putting some intelligence there could be very helpful. Security cameras are also now becoming more widely deployed, but today a lot of these cameras just sit there and they broadcast video up to the cloud 24/7, and I mean, first of all, that uses a lot of bandwidth, and second of all, you have all of these privacy issues again. So if you had some intelligence built into the camera that would be able to look at the image and say, you know, that's just the same street I've been looking at all day. Nothing's happening. I don't need to send it up to the cloud until somebody actually comes to the door or something else interesting happens. Then you can really cut back on the amount of data that is being transmitted and analyzed in the data center. So, so there's a lot of work being done to add intelligence to these security cameras. Drones are also getting more intelligent. Some of the higher-end drones now can pilot themselves to some extent. They can go out, they can return to base on their own, and so that's becoming a selling feature of these high-end drones. Now, you know, we are seeing a lot of activity in the IoT, particularly in the industrial side. The deployment now of in smart buildings is starting to catch on. Smart meters, of course, have been around for years. Smart parking, you know, you'll see a lot of the parking lots in this area and in other areas now are able to detect which spots are open, how many spots are open. You know, the reason is that there's generally a good business case, you know, for these types of IoT products. You know, if you can reduce the amount of energy being used for heating and cooling in a large building, you know, that can easily pay for the cost of the installation. If you can eliminate the need for meter readers, smart meters have been very successful. The type of parking systems can improve the efficiency and help more people get into the parking lot on crowded days. That helps improve revenue for parking areas. So as long as there's a business case, you know, it pays for this implementation. And as we see, you know, some areas implementing these technologies successfully, it encourages, you know, other people to do that as well. So this type of deployment is starting to really catch on. And then in the consumer space, it's been a little bit slower to take off, but we are seeing some stronger activity in the past year or so. The smart thermostats, smart doorbells with the security camera built in, smart lighting. So there's been a lot of pickup in this home automation area. We see the prices are starting to come down, so you don't have to spend, you know, $200 anymore to get a lot of these devices. And you know, so you know, Amazon, for example, is talked about selling over 100 million of their Alexa-based devices. So this technology is getting out there, and you know, and once these IoT devices are being deployed, I think we'll see more of them over time that want to take advantage of doing some of the AI processing in the device. I mentioned smart cameras. We're seeing a lot of chip vendors targeting this smart camera market. A lot of this is being driven out of China, where the government has talked about deploying 200 million cameras in their security system. And then they want to build face recognition into a lot of these cameras in order to be able to know, you know, who's on the street, who's in a given area, and be able to monitor for you know, whoever they're trying to keep track of. So a lot of chips now are targeting this type of application. You know, the standard spec seems to be about 1 teraop per second in order to do face recognition, like in the example here, that you want to be able to identify, you know, multiple people in the frame and perform face recognition to try to identify all of those people, you know, in real time, you know, 30 frames per second, you know, using about 1 teraop. So Intel has something called the Myriad X through their acquisition of Movidius a few years ago that offers 1 teraop. And Bitmain, a Chinese company, has another processor with a similar specification. We've seen other similar products from Canon, another Chinese company, Cambricon, HiSilicon, Horizon Robotics. So these companies are all targeting this burgeoning market for surveillance cameras, but the chips can also be used for other similar applications in the IoT space to identify different types of sound data, different types of image data, smart parking. So we'll see these types of chips as the cost is being driven down by this competition, enabling new markets that can use these capabilities. And then for even smaller devices, particularly battery-operated devices, you need very low power processors, and typically we see microcontrollers in these types of small sensors in order to minimize power. And you can run small, simple neural networks on a microcontroller, particularly if you have one that has some kind of DSP capability built in. But if you really want to minimize the power that's being used for these neural networks, then it helps to put some sort of even a small AI accelerator onto these chips. So Compute is a startup that has a microcontroller with this CoolFlux DSP accelerator that they've benchmarked using 15 times less energy when running these neural networks compared to a standard CPU. And then GreenWaves has a RISC-V based microcontroller, which again, they've demonstrated scaling down to very low power and much more power efficient than using a standard CPU. So I think there's an opportunity here for these very small IoT devices to have these AI-enabled microcontrollers.